Yeah, hi. So in this video, we are going to discuss about digital signature. And so let's say you want to ensure that you have received a correct document, message, or a software from the correct recipient. So here, it could be a message, or it could be a document, or any software code. So you want to ensure that it is tamper proof, and and tomorrow the sender cannot deny that he has not sent that message. So no one should tamper with the contents. That's the first thing. No one should be able to tamper with the contents. And here the sender also cannot deny that he has not sent the message. So that's where digital signature comes into picture. So digital signature is a technique to validate authenticity and integrity of the digital document, message, or a software which is sent. So here two things are important. First is the integrity of the message and the authenticity, which we described in the earlier slide. So it's nothing but a digital equivalent of handwritten message or stamped seal. So these are the basic features of it. First of all is the authenticity. The signer is confirmed as the signer. And second is the integrity. The content has not been tampered. And this is non-repudiation, means the signer cannot deny the association with the signed content. So digital signature here uses public cryptography, where a mathematically linked pair of keys are created. Here both private and public keys are created. So let's understand a scenario wherein there are two users, Jim and Tim, and Jim wants to send the document to the Tim here in this scenario. So what will happen in the first step is Jim will create two keys, okay, public and the private keys here. That's the first thing he'll do. Public key he can share it with the other users. The private key he will not share it with anybody. So he'll use it to encrypt his message, which we will see in the next slide. Okay, so Jim, what we'll do is he'll first hash the message which he wants to send to Tim. So this is the message which he wants to send, and he's going to hash it with an hashing algorithm, and he's going to get the hashed message here. Now, the hashed message which we got in the previous slide, here we are going to use a private key. So Jim is going to encrypt the hashed message with the private key, and this is a combination is going to create an encrypted message. So we have the message, we hashed that message here, and after that we encrypted that message using the private key. Now we have this encrypted message here. So what we are going to do is we are going to send this encrypted message to Tim, but along with the encrypted message, we are also going to send the plain text message which is not encrypted here. So which is the message in the step 1. This is the message we're going to send. So in this step, there are two things. There are message, and the encrypted message is going to be sent to the Tim. Okay. Now what he's going to do here is he will take this message, okay, and he's going to hash that message again with the hashing algorithm and get the hashed message. So Tim has two things. One, he has the message, and second is the encryption message. So Tim is going to hash the message using the hashing algorithm. So this is the hashed message. Now he also has the encrypted message here. Okay. Now, so what he's going to do here is he's going to decrypt that message with the public key, and this public key belongs to Jim. Okay, this is a public key which Jim has shared with the Tim, and he's going to decrypt this encrypt message using the public key, and he's going to get the hash message back. So here in this scenario we have two hash messages, one from the plain text message and one is from the encrypted message. Now both the hash messages are checked. If both of them are equal here, that means the message is not tampered by anyone in the way. So here we got the message, we hashed that message, we encrypted with a private key, and we got the encrypted message, and we sent both the messages in plain text message and the encrypted message both to the Tim, and Tim has hashed the plain text message using the hashing algorithm, and he has decrypted the encrypted message using the public key to get this hash message. If both are equal, that means the message is not tampered. Yeah, this slide is showing the same thing, that both the messages are not tampered here. Like if both are equal, And if one of them is different, that means definitely the message is tampered. So there's a problem with the message which we received. Somebody might have tampered it, so we get two different messages here. So where are these used? What are different use cases for digital signature? First, the government may use the digital signature for budget documents, laws, bills, and tax documents. Okay, so there are various scenarios. So all those business documents, laws, and bills will be government will use a digital signature. For healthcare, also are used for patient records, prescriptions, and consent forms. And for financial service, digital signatures are used for contracts, paperless banking, loan processing, all your insurance documents. So in financial service, it is used most. In IT services, for example, digital signatures are used for software distribution, code signing, and all. So these are the use cases. And for the definitely for the real estate services, digital signatures are used for sale agreements, all your lease and rental agreements, mortgage papers. So we can just use digital signature for them. So in summary, we know what is a digital signature. It's a technique for validating technique to validate authenticity and the integrity of the digital document, message, as a software. So this is the entire flow which you need to remember, and these are the use cases which we are using.